Hello everyone, I am Prem Deep, a student of Engineering Physics IIT Roorkee. Today I am going to give a presentation on a topic which is potentiometric error detector. So firstly, let's have an overview of the presentation. So the first thing that I will discuss is introduction part, and before discussing potentiometer as an error detector, firstly we will learn about potentiometer, and this section consists of three further subsections, and these are the definition of potentiometer, and then construction of potentiometer, and then the working of potentiometer. And then after we will discuss how potentiometer can be used as an error detector, and in the last we will see the applications. Now introduction. So all the feedback control system operates from the error signal, and this error signal is generated by comparison of desired reference and the output. So you must be thinking, why am I talking about feedback control system here? So the thing is, in the case of potentiometric error detector, we will doing the same thing, where we will use two potentiometer which is connected parallelly, and one of the potentiometer will be used as reference and the other can be controlled to give an error signal corresponding to the error in the angular position of the shaft of the potentiometer. You will have better idea of this when we will go through potentiometer as an error detector part. For now, let's move to understand about potentiometer. What is potentiometer? So the potentiometer is defined as a 3-terminal variable resistors in which the resistor is manually varied to control the flow of electric current. So now let's try to understand this definition with the help of this image of potentiometer. So as you can see here, there are 3 terminals, this one, and there is some resistance involved between these terminals, which you will understand in the construction part. And these resistance can be manually varied by rotating this knob. This knob is free to rotate, and if you rotate it, then the resistance between these terminals changes. And since we are changing the resistance between these terminals, then if we apply a constant potential between the terminal, then the flow of electric current will be changed. Now if you read this definition, you will understand what this definition is trying to say. Now let's move to the second definition here. So the potentiometer can also be said as it is an electromechanical transducer which convert angular or linear displacement into proportional electrical voltage. Now let's try to understand the construction of potentiometer. So it consists of a resistive element which is circular in shape in case of rotational type of potentiometer. This is the resistive element of potentiometer, as you can see in this diagram. It has a certain ohm per unit length of resistance, and which is preferably should be constant throughout the length. And there is a wiper which basically is a good conductor, good electrical conductor. This one is wiper, and there is a knob, this one, and this knob is connected to this wiper, and when we rotate this knob, then this wiper slides over this resistive element, and when it slides on this resistive element, the resistance between these terminals changes. It is very much clear from this diagram, because it has a certain ohm per unit length of resistance, and if this length changes, then obviously the resistance between these terminals will change. Okay, so now let's see the working of potentiometer. So firstly, let's see the circuit diagram of potentiometer, this one. So as you can see here, there are three terminals, 1, 2, 2 and 3. This terminal is same as we saw in the construction part. These two are fixed terminal, and this is the variable terminal through which the wiper were attached. So if you want to understand this with the help of previous image of potentiometer that we saw in the construction part, then when we rotate the knob of potentiometer, then this resistance R1 and R2 changes, and R1 plus R2 will be always equal to R, which is actually the total resistance of resistive element. So here what we are saying is, when an excitation voltage is applied across the fixed terminal, this one, then the output voltage measured at the variable terminal, that is 2 and 3, will be proportional to input displacement. And let's see this equation. This equation is actually for rotational type of potentiometer, where theta t is shaft position and et is basically the output voltage. Here the output voltage is V out. So as you can see, the output voltage is proportional to the shaft position, and this is very much important result of potentiometer, that the output voltage is proportional to the shaft position. So this is how potentiometer works to give different output. So now let's understand how potentiometer can be used as an error detector. So when two potentiometer is connected in parallel and same output voltage is applied to both, then a comparison between two shaft position can be done, that is between a reference shaft and a controlled shaft. So let's understand this with the help of this circuit diagram. So here are the two potentiometer, this one and this one, and these are connected parallelly, and same output voltage V is applied to both, and we are basically making comparison between the shaft position of this, that is theta 2 and theta 1. Here theta 2 is reference shaft and this one is controlled shaft. Now since the reference shaft is fixed, which means the output voltage across variable terminal will be constant throughout the process, and we are basically rotating the shaft of controlled shaft, and hence we are getting different output voltage for this theta 1 potentiometer, and this error signal is basically the difference between the output voltage of both potentiometers. And when we relate the error signal with the angular position error, then we observe that it is proportional, that is error signal is proportional to the angular position error. as you can see from this equation. And this linearity can be proved analytically also, and this can be proved by having an experiment in the lab using potentiometric error detector kit. So here is the potentiometric error detector kit. With the help of that we can show the linearity of that equation. So now let's move to the application part. So this can be used to control the rotating speed of a motor. So what is done here, this is the potentiometric error detector. So the error signal is firstly amplified, and this potential is applied to a DC motor. So when we rotate the shaft, that is the controlled shaft, then this error signal changes, which means the potential between the terminal of DC motor changes, and hence the speed of this motor changes. So these are the references from where I have studied and made the presentation.